In this graph, I'm going to give you some general equations for some periodic functions. The first general equation of the periodic function for sine x is when we've got some transformations occurring. So A stands for the amplitude change, B affects the period, and D is what we call a vertical shift. And you can see that I've written a general equation for sine and a general equation for cos. In order to sketch these graphs or to find the equations, you need to know the key features for the sine graph and the key features for the cosine graph. So let's just talk about what the period is. So the period I said was affected by B. Depending on if your domain of your graph is in radians or if it's in degrees, you're going to use one of two formulas to calculate the period. The period of a graph is 360 degrees divided by this B value. So that's the coefficient of x. And of course, if we're looking at that in radians, it's going to be 2 pi upon the coefficient of B, or the coefficient of x, which is B. Now, this general equation for a periodic function only talks about what happens when there's a vertical shift, or a period change, or an amplitude change. It doesn't talk about what happens if there's a horizontal shift. If you'd like to look at a horizontal shift, you'll need to look at periodic graphs extension video. So let's have a look at how the period is affected. So if I pick a graph, for example, let's go with y equals 4 cos of x upon 3. Well, let's have a look at what that is. The A value, we can see if we can compare it, we're dealing with this cos equation, we can see that the amplitude is now 4, not 1 anymore. If we have a look at the B value, the coefficient of x is 1/3. So we can say that B is 1/3. So how do we then calculate the period? Well, we use the formula. I haven't specified whether we're going to do degrees or radians at this point. Let's assume radians if it's not stated. So we'll go with this one here. If we've got the period, to find the period, we're going to do the period equals 2 pi divided by B, and B is 1/3. When we divide fractions, we multiply them by flipping finding the reciprocal. So of course that's 2 pi multiplied by 3 tells us that the period of this graph is 6 pi. That's more than one cycle of an ordinary sine graph. So we've obviously tripled our period. So if we're going to sketch that, we have a look to see if there's a value of D. There is no value of D, so our equilibrium position still stays at 0, which is along the x-axis. We haven't moved up. We know that there's been an amplitude change of 4. So we look at the graph of cosine. So I'm going to draw a very small sketch. We know that the graph of cosine during one period looks like that. However, what's occurred here is the amplitude is now 4, so it goes from 4 to -4. And of course, the period of one full cycle is 6 pi, which means halfway along is 3 pi. So 3 pi is here. And of course, a quarter of the way along is 3 upon 2 pi. And of course, you can then work out the next one, okay, which is 9 pi upon 2. And that's just a very, very basic sketch. You can see here that I've got the key features on there, the x-intercepts, the y key features giving us the amplitude, and all I need to now do is label the x and the y axes and write the equation of the graph.